Okay, hope everyone had a good weekend. Welcome to Unit 9. Unit 9 you might like a lot of it because it's a little different than what we've been doing all year. It has a little bit of geometry, but nothing with circles, so you're good there. We're building on things you've learned before and just learning a few extra things, a few new vocabulary words, things like that. So for the do now, we just want to recall what the formula is for finding the area of a square and for finding the area of a rectangle. So if you want to pause the video here and see if you remember it, write it down. As you're writing it, I'm going to draw a rectangle and a square really quickly so that I can refer to it and label it. All right, I'm actually going to start with the rectangle first. And a rectangle has two dimensions. Remember that a dimension is just different ways you can measure something. So you can measure a rectangle this way and this way. And I've seen them called two different things. I like to call them length and width, but I've seen them also called base and height. So I'm going to call this bottom side the length and this side the width. But you could call that base and height. And the area for a rectangle is length times width. Notice I didn't put any symbol in between those two letters because when it's multiplication, you don't need a symbol. You can put a dot if you want to. Do not use an X since it's just going to look like another letter. So this is the area formula for a rectangle. Also, we said it could be base times height if you chose to use those, but both of those are correct. Now for a square, I'm going to split it here. For a square is a rectangle. In 10th grade geometry, you're going to learn all about the properties of different shapes. And one of the things you'll learn is that the properties that make up a rectangle, a square also has those properties. So it is a rectangle. So we can use the same formula, length times width. Except squares have a very special property. And the very special thing about a square is that all four sides are exactly the same length. So it doesn't make sense to use two different letters to call length and width. Since they're all the same, if I just call it S, which in this case stands for side, instead of length times width, it's just going to be side times side. But when you multiply something by itself, we can just use an exponent. So the area formula for a square is side squared. You're just taking the length and you're multiplying it by the width, just like with a rectangle. It's just that all the sides are the same. So those are the formulas to find the area. Now, the launch is what does it mean to find the area of a shape? And this is important because you have to know when to find the area and when to find other things. If you ask anyone, a high schooler, a college student, an adult, what is area? A lot of them are going to say length times width. But that's just the area formula for a rectangle. That's not what area is. So what does it mean to find the area of a shape? When you find the area, you are finding how many square units fit inside a shape. I'm going to make this so it looks a little nicer. How many square units fit inside a shape? Or, I'm going to change it to a different color. How about green? Another way of saying that same thing is how many square units a two-dimensional shape takes up. How many square units or how much space a shape takes up. We're only talking about flat shapes here. Area is a two-dimensional measurement. It is a flat measurement. When you get into 3 dimensions, you start talking about things like volume. This is area. So in the example above, when we were finding the area formula for a square, you're really finding how many square units fit inside of this object. Same thing for the rectangle. So here's a shape. It's not a regular shape. It's an L-shaped figure. It has 1, 2, 3, 4, 5, 6 sides. So do you know the name of that shape? If you don't, maybe it's a good time to look it up. So there's not a regular formula for this shape because it's not, a straightforward shape like a rectangle or a square. But without using a formula, how could you find the area of this shape? Well, since it's on a coordinate grid, we can just count the squares. Remember that area is how many squares fit inside of an object. So I can just count how many squares there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So the area of this shape, this L shape, is 23 square units. I'm writing square units because we don't actually know what the units are. You could abbreviate that to square units like that. Or if you really want to get fancy, 23 units squared. That's an exponent of a 2. Because once it becomes like inches or centimeters, this is how we're going to write it. You can only do this method when the squares are full squares. Don't estimate. So if for some reason they give you a shape like, I don't know, like this, we can't do this method because you can't count the squares there. It's not perfect. So only can do this when it's perfect. All right, let's move on to the next page. Here's some graph paper. You can, if you have graph paper, use it. If you print this out, which I'll attach this, you can use it. They want you to draw different things. So the first one, they want you to draw a square with an area of 16 square units. And there's only one possible answer for that square. So I go down to my graph paper. Well, if it has to be a square, all 4 sides have to be equal. And it has to have 16 squares inside of it. So I'm going to draw one right here as best as I can with my finger. I ordered a stylus, it's in the mail, and then hopefully we get a little neater. So there we go, there's a square with 16 squares inside of it. So the first one I did in blue, you can see right there. The second one, we want a rectangle with an area of 14. I'm going to do it in red. There's multiple options for this one, but I'm going to take the easy way. I'm going to go 7 boxes up and down. And then 2 boxes across. And I know that's correct because I can count the boxes in front of it. That's a terrible rectangle, but we're just going to deal with it. Or I could do the formula and do 2 times 7. Now I'm going to draw a parallelogram. I'm going to do this in green. A parallelogram, if you don't remember, kind of looks like a slanted rectangle. It is a 4-sided shape where both pairs of opposite sides are parallel. So again, I'm going to do 1, 2, 3, 4, 5, 6, 7. And then I'm just going to draw a slanted side like that. And I'm making sure that the height stays at 2 because the area formula for a parallelogram, and I don't know if we mentioned it, but this is something you've learned before. The area formula for a parallelogram is base times height. And really quickly, I just want to point out that this bottom side is the base. The height is not the slanted side. The height is how tall it is from the top to the bottom by drawing a straight vertical line. And now we need a triangle with an area of 7. So this is going to be tough because when you draw a triangle, it's going to cut off some of the boxes. But there's a trick to this. If this rectangle is 14, this red rectangle that's there, well, if I cut that in half with a diagonal line, then I have 2 triangles, and each one of those has 7 units. And that's also where the area formula for a triangle comes from. You just take the area formula for a rectangle, base times height, and you cut it in half, because that's what I just did to make a triangle. You will also see that written as 1/2 times base times height. So these are the formulas for a triangle. All right. Well, I just kind of talked about this, but we will talk about this again. Think about a triangle in relation to a square or a rectangle. Can you identify the relationship between each? Well, you can see in this picture that they give you a gray rectangle, and they draw a diagonal line and cut it in half, and they make two equal triangles. That's the relationship between triangles and rectangles. Any triangle, I can take any triangle and complete it into a rectangle, and it'll be exactly half the size of that rectangle. And that works for any triangle, and that's where the formula for a triangle comes from. Area equals 1/2 base times height, or area equals base times height divided by 2. Those are both the same thing. Here's an example. So first, let's find the area of this rectangle. So area equals length times width. Notice that whenever I use a formula, the first thing I do is I write it down, and then I plug in the numbers, substitution, 4 times 3. I ran out of room. Area equals 12 square centimeters, or centimeters squared. So find the area of the triangle. Well, each one of these triangles is exactly half the size of that, so I know the area is going to be 6 square centimeters. But let's do it using the formula. Base times height divided by 2. And if I want to go sideways, I can. So 4 times 3 divided by 2. That's 12 divided by 2, which is 6. And then I include the unit, which area is always measured in square units. In this case, it's square centimeters. So here's some rectangles. You should practice this on your own, so pause the video and write down the answers. Don't just write the answers. I know some of you are looking at number 1 and you can tell me the answer almost immediately. But what I need you to do is practice using the formula. Because when you get to 8th grade or even higher, and you get to more confusing shapes like trapezoids or volume of spheres and things like that, or even if you go back to area of circles, you need to know how to use a formula. So practice. All right, so I'm going to start doing the answers on the board. So if you want to do it on your own, you need to pause the video. So this is a rectangle. I know the area of a rectangle is length times width. Now I'm going to substitute in, that's 5 times 2. And I get 10 square centimeters. For number 2, I'm going to use the other formula, area equals base times height, just to show you that it doesn't matter. And that would be 3 times 8. And I get 24 square yards. Remember that the area formula comes from how many squares fit inside. So if we look at number 1, the height is 2 centimeters. So I'm going to split that up into 2. And the width, or the length, sorry, is 5 centimeters. So I'm going to split this up into 5. And notice I just made a bunch of squares. How many squares? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's where this 10 comes from. It's just how many squares. Same thing here. 3, and then 8. 8 is going to be tough. Hold on. So that's 4. So now if I split each one of those in half, I should have 8. There we go. So now how many? I have all these boxes. There's 24 of them. Same as the answer. Let's do the challenge, because in class, most times, some of the students get to the challenge if you have extra time, but since we're at home and we could pause the video, let's do the challenge. A piece of paper has a length of 16 and an area of 48. So I'm going to draw a piece of paper, and it says it has a length of 16 inches. And it says that the area is 48. Find the width. So I'm going to put an X there, or you can put a W. This is where I can use the formula. Area equals length times width. Now I'm going to substitute. I know the area. The area is 48. And I know the length, 16. I don't know the width. So now this is just an equation I have to solve. In order to figure out what W is, I need to get it by itself, so I need to get rid of that 16. When you're solving an equation, to get rid of something, you have to do the opposite. Since this is multiplication, I'm going to do division. I can cross that out because 16 divided by 16 is 1. On the other side, I need to do the same thing. That's called the balance method. 48 divided by 16 is 3 equals, and then all that's left there is W. So the width is 3 inches. All right, here's two parallelograms, and you have to figure out the area of them. The area formula for a parallelogram is base times height. So I write that down. Notice in the first picture, the height is not the slanted side. Think about when you go to the doctor and you measure your height. They tell you to stand straight up. So that's the height, the line that's going straight up and down. So the area equals 7 times 3. 7 times 3 is 21, and the units are going to be square millimeters. This other one, it's drawn on its side, and that's kind of confusing because you might think that this 6 is the height, but it's not. That is still the base. You have to imagine if this was right side up. So area equals base times height. The base is 6, and the height is 2. They wrote it outside the shape, but they used a dotted line. They're just showing you how tall it is. So that would be 12 square inches. We're not going to do the whole lesson. So don't worry, there's only a couple more slides, and then we're going to call this lesson 1A, and then we'll do a 1B separately. So the perimeter of a square rug is 36 meters. Find the area. Very interesting. So it's a square rug, and they're talking about perimeter, not area, so don't get confused here. Perimeter is when you add up all 4 sides. But since all 4 sides are the same, I can just call them each S, or X, whatever you want to call them. And we know that the perimeter of a square, and there's 2 ways to write this, is either S plus S plus S plus S, or, since you're just adding the same thing 4 times, 4S. So I'm going to use this formula to figure out what S is. I know the perimeter is 36, and I don't know S. So this is, again, a one-step equation. I need to figure out what S is. To do that, I need to get rid of that 4. I need to isolate the variable. So to get rid of the 4, I'm going to do division. And I see that S equals 9. All right, here's 2 triangles to find the area of. The area formula for a triangle is base times height divided by 2. Again, notice that the height is a line that goes straight up and down, not the slanted side. So 6 times 2 divided by 2. So I can either do the 6 times 2 first, get 12, then divide it by 2, or I can see that, well, there's a 2 on the top and a 2 on the bottom, so they cancel each other out, and I'm left with 6 square inches. For the second triangle, I'll use the other formula, 1/2 base times height. So area equals 1/2 times 5 times 4. I could do this all right on my calculator in one shot. Or again, well, I can cross cancel. I can just 5 times 4 is 20, and then half of that is 10. There's different ways I can do it. But it comes out to 10 feet squared. Triangle ABC has a base of 4 units. Let's draw a triangle. Whenever I draw a triangle, it's nice to draw a right triangle like this, because then the height is just the left side or the right side. So it has a base of 4 and a height of 8. And this is ABC. And then it says triangle DEF. And I make sure I letter that in the same way I lettered the first one, has twice the base and height, so that would be 8 and 16. Describe how the ratio of the bases is related to the ratio of the areas. Well, first, okay, let's write a ratio of the bases. So ABC to DEF. Those are the 2 triangles we're looking at. And first, we're going to look at the bases. The base of ABC is 4. The base of DEF is 8. If I simplify that, I get 1 to 2. So now if I want to do the same thing with the areas, well, let me just extend this page. First, I'm going to have to find the area. So the area is base times height divided by 2, which is 4 times 8 divided by 2, which is 16. And the area of this one is base times height divided by 2, which is 8 times 16 divided by 2, which is 64. So the ratio of the areas is 16 to 64. And if I simplify that on my calculator or using my knowledge of common factors, I get 1 to 4. So very interesting, they do not have the same ratio. So that is something to keep in mind. All right, that's it for lesson 1A. We'll stop there. Keep checking Google Classroom for your assignments. Keep up with all the work. If you have questions, make sure you are contacting us. We will help you in any way we can. We can make some shorter videos. We can find some good videos on YouTube to show you. We can try to help you just via written feedback. Or we're going to go live. We go live 2 or 3 times a week. Sometimes it's with me. Sometimes it's with Ms. Longo. Sometimes it's with both of us. So keep doing what you're supposed to be doing. Let's, keep doing the right thing. Hope everyone is doing well and staying safe and healthy. Have a good day.